Hello, welcome to the second episode of Tech Flourishing. So in this episode we're going to take a look at tables. Pretty simple concept in some ways, but another one that is a gift that has kept on giving. So way back from when I first learned what a table was, and that was probably at primary or junior school, as a way of organising information in a certain way. That concept of a table and how it might be used and how it crops up, I've revisited more times than I can probably count. And in this episode, I'm just going to do a few examples of how the concept of a table has manifested itself in various ways throughout my education in technology and also working within technology. But this is really just scratching the surface. And again, just putting this together, you uncover all sorts of really interesting facts that either you didn't know about or have forgotten about. So let's start off with the table article on Wikipedia. So a table is an arrangement of information or data, typically in rows or columns, or possibly in a more complex structure. Tables are widely used in communication research and data analysis. Tables appear in print media, handwritten notes, computer software, architectural ornamentation, traffic signs, and many other places. Now, the other thing it's just reminded me of when I was doing this, in addition to sort of, learning at school how to use tables to contain data, one thought that's just suddenly bounced into my head is I can remember it would have been junior school, so I would have been under the age of 11, being involved in what they called the school bank. And as part of that, and that was my reward for doing well in a math test, the school used to operate this bank, and we were using like accounting tables to keep track manually of the account balance on the kids at the school. They could set up like a bank account, and it was used to keep track on that. So that's another thought that's just suddenly bounced in as I'm talking about this. But alongside that, probably in parallel with tables and learning them how to lay them out, was a sort of mathematical aspect, and that's matrices. And I can think of, probably feels like hundreds of times or hundreds of hours spent learning matrix multiplication and all the mathematics around combining one matrix with another, and links to linear algebra, and all the other things that are facilitated when you start to get involved in matrix multiplication. So I learned this early on, and again, I've probably lost count of the amount of times I've revisited matrix multiplication in various guises over the years. Oh, there we go, yeah. Vectors and matrices. So I'll include links to all of these articles. So if it's an area you want to reacquaint yourself with or dive into as a good example of like an evergreen piece of knowledge or skill that certainly for me I've used over and over again when working in technology. So later on, when I was in secondary school and I started to actually learn computer programming, the whole concept of an array came in. So it's a data structure, and obviously you can see here, because the mathematical concept of a matrix can be represented as a two-dimensional grid. Two-dimensional arrays are often sometimes called matrices. In some cases the term vector is used in computing to refer to an array, although tuples rather than vectors are the more mathematically correct equivalent. So there's all sorts of spin-offs in this. The other thing that's interesting with arrays, and certainly in the language that I learned in, which would have been BASIC, like original BASIC as it was done on the Commodore PET, and other flavours of BASIC I worked in, it was relatively easy to work in multi-dimensional arrays. So to go from two-dimensional arrays to just keep adding a dimension to the array. And I remember once, probably a couple of years after I left school, when I got my hands on the first computer at home, we had at home, which would have been, I'm just trying to think now, not a Commodore 64, but a Commodore Plus 4 it was called. And trying to design this dungeon crawler game, it was just a text-based one, and I was going to do it by having arrays, multi-dimensional arrays, not only to sort of signify tiles on the floors of a dungeon, and each room would be its own array, but also within that have layers of it which would represent, say, treasure or creatures or other things. And as I increased my multi-dimensional array by one, as I thought, oh, this needs to have an array as well, I ran out of memory. So yeah, that always reminds me to be mindful of the limitations of multi-dimensional arrays when you're working on systems that easily allow them. Of course, a lot of programming languages now will come on to data structures. You can have data structures inside of data structures as well, which is its own can of worms, I suppose. So, obviously I learnt about arrays when I was learning programming at school. Once I left school, I think, outside of doing further programming, when I worked in science and within the area of bacterial identification and immunology, so obviously it carried over into that, and we were programming on Apple IIs and some of the early Dell. So before there were Dell microcomputers, there were Dell mini computers. Before there were Dell PCs, DECs. I'm getting muddled up here. So we were working on DEC. I think they were called microcomputers before the term PC was used. And on there, I'm trying to remember the programming on there. I think it was Pascal, but I don't remember dabbling that heavily in it. But I do remember programming on BASIC on the Apple II, and then subsequently in Quick Basic on IBM clones like the Amstrad. So there was this just continual use of arrays, but off the back of that, we used to use arrays a lot in numerical taxonomy. So a lot of and I'm not going to go into any great detail about numerical taxonomy. There's so many factors within it to do with probability, taxonomic units, phonetics, weighting, dendrograms, but a lot of the data in terms of the probability matrix. Well, it's a probability matrix, so it's stored in matrices. And so at some point I got involved quite heavily in again doing sort of matrix stroke vector multiplications using probabilities, where you were sort of effectively multiplying the matrix by a vector, and the vector contained a test result, and that gave you, by using some clever maths, and you know, these were all based on concepts developed by Sneath, who I was more aware of actually at that point, and being able to do bacterial identification and things like taxonomic distance. And there is another thing we used to do as well, like to do with I can't remember the term now, but there were two calculations that were performed. One was the probability, but the other was the probability of it being a certain organism versus other organisms that it could be. But then there was a differentiating calculation which would tell you how close it was to other organisms where there might be problems, and there's a good chance that you may misidentify it beyond just its basic probability. And that was more based on the distance taxonomically between one cluster of species of bacteria and another cluster, sort of mathematically. So that was super interesting, but we used matrices and arrays and vectors a lot for doing that. That would have been mainly in the 80s. But through my exposure also to doing programming within a quality control environment, again, a lot of it used tables. I was exposed to the 7 basic tools of quality, but subsequently on a course I did as part of my postgrad, which would have been in the 90s, I became aware of the seven management planning tools, which are often called the 7 new. So these are the 7 basic or the 7 old tools of quality. These are sometimes referred to the 7 new tools of quality. And in amongst these are prioritization matrix and a matrix diagram or quality table. So I'm back at tables again, but again used in a different point, because they then got spun out into something called quality function deployment. You can see with quality function deployment, it very much is table city. Look at all this stuff going on here. So yeah, this was fascinating, playing around with QFD. So another manifestation of tables. Here, you're not necessarily, well, you can do mathematical calculations within this, obviously. You can see down here. But also, you're using symbols as well within the table. There's a legend there as well. So that was sort of in the 80s into the 90s, but also in that changeover period, from when we were first using mainly IBM clones like Amstrads in the labs, I got exposed to things like SuperCalc and Lotus 123, and then retrospectively I became aware of VisiCalc. So here, you know, a table is manifesting itself in the form of a spreadsheet. And so again, table formats, and there's a whole load of things you learn when you learn spreadsheets in terms of how you access cells and how the functions work and various other things. What was interesting is there was a version, I think, of Computer Associates made a variation of SuperCalc, which was a multi-dimensional spreadsheet as well, which I remember dabbling in. So this is around the period when, of course, before Microsoft Excel got into domination. And then sometime in the mid to late 90s, I got exposed to relational databases and all the different table related things you learn around that, to do with not only how relationships work and keys, but things like schema and how to design relational database tables as well, sort of structurally. So now I'm getting into areas of how one table may be related to another in terms of certain primary keys in rows. And of course it was inevitable tables manifested themselves in web page design. So in HTML, when I was doing some web design, I got, to, and it's funny, I can remember, anybody that remembers back, before they got their hands on something like, was it Macromedia? Used to make a product. I want to say Fireworks, but I may have got the name of the product muddled up. But there was a Macromedia WYSIWYG web design tool, and when you got your hands on that, it completely transformed your life. And prior to that, I'd had to do this all by hand. And anybody that's had to do this by hand, yeah, it's great fun. So yeah, that was another exposure to tables. And then at some point I ended up revisiting data structures. I think it was probably the first time was when I started to learn Python. So that would have been sometime in the, 2010s maybe. All through the 2000s, what was happening really when I worked for myself was I was sort of, reapplying all these other things that I'd learned in various different formats, because I was just dealing with so many different clients. So, I was using tables in spreadsheets, in quality control related aspects. I revisited numerical taxonomy at some point because I just wanted to dabble in that and do some programming in Visual Basic and reimagine some of the early programming I'd done in Basic, in Visual Basic, in terms of numerical taxonomy programs and the like. So a lot of the 2000s I just spent going back over that, and when I got into the 2010s, and I went from I suppose randomly learning things like dabbling in C and C++ and a couple of other languages, then sort of properly going through and starting to kick the tires of a Python and experiment, because then I'm reintroduced to data structures within Python, but also off the back of that starting getting into how data structures work in other languages, like recently Rust, and before that, in some capacity I was playing around, I think, with F# and trying to think of the other one now, the name of it's gone. But yeah, it was just interesting to see how the concept of data structures manifest themselves and are handled in different programming languages. And then that was only inevitable as I dabbled in mainly Python. I'd start to explore more data science and took a series of courses through Microsoft about data science, and of course then had to manipulate tables and various other things within primarily Python, but also things like SQL, because of course when I was learning relational databases originally, I spent a lot of time in SQL, and then in MySQL ultimately, and then found myself going back when I learned data science on the Microsoft course to, the Microsoft SQL product, particularly, was it transactional SQL, and going through that as well. So it's interesting how that keeps, and I may have to do a separate episode probably on SQL as well. But yeah, certainly lots of opportunity for table manipulation within data science, and within, when you're using Python to do data science. I did kick the tires of R a little bit a while back, and so it's always interesting to see how different programming languages, and ones that are more associated with data science as well, like R and Python, and I think is it Ruby, not Ruby, is it Julia, I think might be the other one, and how they sort of handle and in some ways, through their use of libraries, make it easier to manage the manipulation of tables, and the ability to be able to drop a feature on a table or to clean up a table in certain ways. And obviously certain libraries in certain languages have easier and quicker ways to do that versus other languages as well. So that's just a quick explore of my tech flourishings within the area of tables, and how they cropped up in various places throughout my life. Hopefully that was informative, and I'll include links to all of these articles in the description. Thanks once again for watching. Bye for now, and I will catch you in the next episode.